of benzoic acid is dissolved in 25 grams of benzene shows a depression in freezing point equal to 1.62 Kelvin. That is what given there, equal to 1.62 Kelvin. So we have to write certain things what is given there, equal to 1.62, sorry, equal to 1.62. So let us start writing. What is this? 2 gram. So W2 is equal to 2 gram of benzoic acid is dissolved in 25 grams of benzene. So W1 is given. W1 is equal to 25 grams. Shows a depression in freezing point equal to 1.62 Kelvin. Depression in freezing point is to be written as delta TF. Delta TF is equal to 1.62 Kelvin. Molar depression constant for benzene is, they have given Kf is equal to 4.9 Kelvin kg per mole. Kelvin kg per mole. What is the percentage? What is the percentage of association of the acid if it forms dimer? If it is going to form a dimer, they are asking you what is the percentage of association. Percentage of alpha of A is asked. It is a question mark. For that we have to calculate what is alpha A. Alpha A is a question mark. So percentage of alpha is nothing but equal to alpha A into 100. So we need to know the formula for calculating the percentage of alpha A. First we need to know what is the formula for alpha A. Now it is given that W2 is equal to 2 gram, W1 is equal to 25 gram, delta TF is given as 1.62 gram, KF value is known. From these things we can calculate what is said to be the M2 value. What is said to be the M2 value? What is said to be M2 value? We can calculate it. We know that delta TF is equal to W2 into 1000 into KF divided by M2 into W1. So using this formula we can calculate what is the value of M2, that is experimentally determined M2. M2 will be equal to delta T, M2 will be equal to W2 into 1000 into KF divided by delta TF into W1. So experimentally what is the value of M2 can be calculated. We have to substitute all the values. Substituting you can get, you know what is the value of W2. W2 is equal to 2 grams multiplied by 1000 divided by KF value is 4.9. It is 4.9 divided by delta TF value is 1.62 multiplied by W1 value is 25. Students, using calculator you can calculate what is the value of M2 that you are going to determine experimentally. Experimentally you can determine the value of M2 like this. So whatever value you get, that should be called as abnormal molar mass. This M2 whatever you get, this should be called as abnormal molar mass. Abnormal molar mass. I'm writing in short. A stands for abnormal, M stands for molar, another M stands for mass. Abnormal molar mass can be determined. So use the calculator, solve this, students. You will get the answer as 241.98. This is abnormal molar mass. Once if you know the abnormal molar mass, you can calculate what is the Van't Hoff factor. I is equal to abnormal molar mass, abnormal molar mass. In the numerator you should write normal molar mass. Normal molar mass. Yesterday I have studied the formula for Van't Hoff factor I. Van't Hoff factor I is equal to normal molar mass divided by abnormal molar mass. This will be equal to, so what will be the normal molar mass of C6H5COH? You know, total number of carbon atom is said to be 7, 12 into 7 plus hydrogen 5 plus 1, 6 hydrogen atoms are present. So multiply by 1 plus, you know that 2 oxygen atoms are present, 16 into 2 is 32. If you add this, it comes out to be 122 gram per mole. 122 gram per mole. So you'll get what is the value of what is the value of normal molar mass. I think this point is clear, students. Now substitute here. Normal molar mass is 122. Abnormal molar mass, this is what you got, that is 241.98. So therefore Van't Hoff factor I will be equal to, you will get the value of this as 0.504. 0.504. Now you know that what is asked. First you have to calculate alpha A. Can you tell me, students, what is the formula for calculating alpha A? Alpha A is equal to I minus 1 divided by 1 by n minus 1. This is the formula that we have derived in our yesterday's class. Okay, now I value is known. This will be equal to 0.504 minus 1 divided by, so what is the value of n? N is equal to, since it is forming a dimer, n should be equal to 2. So it is 1 by 2 minus 1. So you calculate this. This is coming out as 0.992. 0.992. So implies percentage of alpha A is equal to alpha A multiplied by 100. So that should be equal to 0.992 multiplied by 100. That is equal to 99.2%. What is the percentage of association, students? It is 99.2%. Is it clear, students? Just note down the solution. Is it clear, students? 2.12 NCERT example yesterday gave you as an homework. So since it is a bit different from your all other normal problems that we have solved in the class, I have taken this example. Even though it is a worked example, they have worked out in a different manner. This is one of the easiest method to solve the problem. Okay, shall we go for another problem that I have given? It is also a worked example. So let me go for the next question. This is another example that I gave you to work out. Just read the question, students. Yesterday I gave you, this is NCERT example 2.13. What is given? 0.6 ml. So volume of acetic acid is given. Volume of acetic acid CH3COH is given. This is given as 0.6 ml. And they said that it is having a density of acetic acid CH3COOH is given as 1.06 gram per density as well as volume. You can calculate the mass of acetic acid. Mass of acetic acid is equal to, mass of acetic acid will be equal to density into volume. What is density? 1.06 multiplied by, what is the volume? 0.6. You know that answer will be in terms of gram. So this will be equal to 1.06 multiplied by 0.6. That will be equal to 0.636 grams. This will be equal to 0.636 grams. I think this point is clear to you, students. And also they have given that this is dissolved in 1 liter of water. So given that volume of water is equal to 1 liter, that is equal to 1000 ml. That is equal to 1000 ml. And you should know that use of water, even though if it is not given, you should know that. Now you know that they have given depression in the freezing point observed was 0.025 degrees Celsius. So depression in freezing point is written as delta TF is equal to 0.0205. So we can write it as either degree Celsius or we can write it as Kelvin. Anything is okay. Degree Celsius it is given. Is it clear, students? From these two datas, can we calculate the molarity of a solution? molality of a solution is equal to number of moles of acetic acid divided by mass of solvent in kg. Mass of solvent here is water in kg. So you can get the answer, number of moles of solute, that is given mass is 0.636 divided by, you know what is the molar mass of acetic acid, you can easily calculate what is the molar mass. So what is the molar mass of acetic acid? That is equal to 12 into 2, that is 24, plus 3 plus 1 4 hydrogens, 28, plus 32, 16 into 2 is 32. So you can clearly understand that 24 plus 4 is 28, 28 plus 32 is equal to 60 gram per mole. The molar mass is 60 gram per mole. I think this point is clear, students. Now to find the number of moles, 0.636 divided by what is the molar mass of acetic acid, that is 60, divided by mass of solvent in kg. So 1000 grams is equal to 1 kg. So therefore what should be the answer for this? Solve it using calculator. So it will be equal to 0.0106 molar. Now we got what is the molarity of the solution. Now we can calculate what will be the delta TF. What will be the delta TF using this? Delta TF is equal to KF into M. KF into M, 0.0106 molar. So that should be equal to, without including Van't Hoff factor, that should be a calculated colligative property. So therefore delta TF will be equal to how much? That will be equal to multiply 1.86 by 0.0106. The answer comes out to be 0.0197. So now we know that observed colligative property is given here. This is calculated through experiment without including the Van't Hoff factor. So therefore this should be called as calculated colligative property. Calculated colligative property. CP means colligative property. Is it clear, students? Now we know that Van't Hoff factor I, is equal to, yesterday I have studied that observed colligative property divided by calculated colligative property. So you can calculate the value of I easily. The value of I comes out to be, you know what is observed colligative property, which is given in the problem as 0.0205. This is observed, divided by what is the calculated colligative property, that is delta TF is equal to KF into M, that is equal to 0.0197. So you can use your calculator and see what is the I factor. I factor comes out to be 1.041. I think this point is clear to you, students. Now we can calculate the value of alpha. Since it is dissolved in water, definitely it has to undergo dissociation. You know what is the formula for calculating degree of dissociation? Alpha D is equal to I minus 1 divided by N minus 1. You know that acetic acid would dissociate to give you CH3COO minus plus H plus. One particle of acetic acid dissociates to give you one particle of acetate ion and one particle of H plus ion. So one particle gives two particles. So therefore N value for this is equal to 2. What is the value of N? N is equal to 2. So now I value is 1.041 minus 1 divided by N value is 2 minus 1. So this will be equal to, so you can get the value as 0.041. What is the degree of dissociation? 0.041. Van't Hoff factor we have calculated. They have asked you to calculate the Van't Hoff factor. Already we have calculated. And they are asking you the dissociation constant, that is Ka. In equilibrium chapter, last year you have studied that Ka is equal to C square alpha square divided by C square alpha square divided by C into 1 minus alpha. So without applying Ostwald's dilution law, we got this expression Ka is equal to C square alpha square divided by C into 1 minus alpha. You can remember this from your last year equilibrium chapter. So dissociation of weak acids. So if it is a very weak acid, alpha can be neglected. We don't know what is the value of Ka. They have asked you to calculate the value of Ka. Let us not ignore it. Now, you know what is the initial concentration? Actually, we need to substitute molarity. For a very dilute solution, molarity can be taken as equal to molality. So the concentration C is equal to this. So that is 0.0106 square multiplied by alpha value is given as 0.041 square divided by C value is known 0.0106 into 1 minus 0.041. So substituted all the values for the formula. Ka is equal to C square alpha square divided by C into 1 minus alpha. Now you can solve for this using calculator. This thing can be approximated, this square can be cancelled. So now you can calculate what is the value of Ka. The value of Ka, if you solve it using calculator, comes out to be 1.86 into 10 to the power of minus 5. Solve this using calculator, students. You'll get the answer is 1.86 into 10 to the power of minus 5. Is it clear? Just have a look on the solution, students. Is it clear? So these are the two important homeworks that I gave you yesterday. So rest of the things you can solve. So what all examples are given in your material, you have to work on it. What all solved examples we have done in the NCERT, and what is given as previous board examination questions, answers are given. Just solve that and cross verify it. Solve that and you can cross verify that. Okay, now we have to go for level 1 questions. Is it clear, students? Shall we go for the next part? Yes. You have to go for now level 1 questions. Let us take a look at the first question. Let us take a look at first question. Camphor is often used in the molecular mass determination. Camphor is often used in the molecular mass determination because this was the previous APMT question. This purely theory based question. So camphor is often used in molecular mass determination. We know that camphor is a very volatile substance, and you should know that the value of Kf for camphor is equal to 30 Kelvin kg per mole. Since the value of Kf is very high, which can be used for the determination of molar masses using delta Tf formula. We know that delta Tf will be equal to Kf into N. Since the Kf value is very high, so you can determine the molar mass of a substance using this as a solvent. Camphor can be used as a solid solvent. This is a nonsense reason. It is readily available. This is of course true. It is volatile if you heat it, but that is not the reason why it is being used in the molecular mass determination. It is solvent for organic substance. It is a solvent, so like dissolves in like. We don't have to worry about it. Because of its very high Kf value, due to its volatile nature, so we can determine the molar mass, and the method that we use camphor and we calculate the molar mass is called as Rast-Camphor method. We call it as Rast-Camphor method. No theoretical explanation for this. So since the value of Kf is very high, that is about 30 Kelvin, it acts as a solid solvent which can be removed of the reaction. So therefore, what is the answer for the given question, students? It should be option 4. only theory based, so nothing more to explain here. So just you have to remember it as a fact, and this Kf value is given in your study material, you can refer that. So what is the answer for the given question? Option D is the answer. Option D is the answer. Is it clear, students? Let us go for the second question. Which of the following liquid phase will show positive deviation? If positive deviation should happen, solute solvent interaction should decrease. Means the previously existing interaction between solvent or solute interaction has to be decreased. So when the new interaction, that is solute solvent interaction, should be less than the previously existing intermolecular force of attraction. Now you know that when water and HCl is taken as a mixture, there can be hydrogen bonding between water and HCl. If you take water and nitric acid, same thing can exist. If you take chloroform and acetone, you have seen this as an example for negative deviating solution because of the hydrogen bonding between chloroform and acetone. But when you add benzene to methanol, in methanol there would be intermolecular hydrogen bonding. Intermolecular hydrogen bonding is present in methanol. When you add benzene, this benzene would incorporate between methanol molecules, breaking the hydrogen bonding. When there is breaking of a stronger hydrogen bonding compared to van der Waals interaction between benzene and methanol would be less than the intermolecular hydrogen bonding which is present in methanol. So therefore definitely which is going to decrease the magnitude of interaction. So therefore when you take the mixture of benzene and methanol, that would become an example for positively deviating solution. So what is the answer for the second question? It is option D. Option D is the answer for the second question. I think this point is clear, students. Let us go for the third question now. A solution of acetone in ethanol would behave as. I don't have to explain this once again. Already we have studied in our NCERT. So as I taught you in the class, between ethanol molecules there would be hydrogen bonding. By adding acetone molecule, this molecule would break the hydrogen bonding between acetone molecules, and the interaction would be less as compared to the ethanol interaction when compared to that acetone-ethanol. This interaction of acetone with ethanol is less as compared to ethanol-ethanol interaction. So therefore that should be an example for a solution showing a positive deviation. So what is the answer for the third question? Option D. Option D is the answer. For the next fourth question, let's go for the fourth question now. Cryoscopic constant is the depression in the freezing point produced by. First of all, tell me what is cryoscopic constant. So cryoscopic constant is nothing but Kf. Cryoscopic constant is Kf. Is the depression in the freezing point. Depression means delta Tf. So now we know that delta Tf is equal to Kf into M whenever a non-volatile solute is added. Now they're asking this Kf is what? We have defined it. Cryoscopic constant or molar depression freezing point constant is the elevation in the boiling point, is the depression in the freezing point when the molality of the solution is equal to 1. So therefore answer should be where 1 molar C. Is it clear, students? Okay, now question number 5. Read that question number 5. Question number 5 says that the minimum elevation of boiling point is given by a solution. First of all, let us see the theory behind this. You know that delta TB is equal to KB into M into I if you have the electrolytes. Now you know that KB is constant, this KB is constant, and they have given molality. So molarity variations would be same for all the things. So therefore let us take it as molarity. So delta TB is directly proportional to M into I. M into I. Instead of molality, we can take it as molarity in this case. Is directly proportional to M into I. I think this point is clear, students. Now, if M into I is more, which will implies that delta TB is more. Delta TB is more. We know that delta TB is nothing but equal to TB minus TB naught, where TB is the boiling point of the solution, TB naught is the boiling point of the solvent. If delta TB is more, you know that this is a constant value, so which will imply that TB is said to be more, since TB naught, boiling point of a pure solvent, is said to be constant. Is it clear, students? So you have to remember that if delta TB is more, boiling point of the solution is also more. I think this is clear, students. Now this delta TB depends upon what? M into I product, where M is molality, but here it is given as molarity. You can take it as. Now they are asking which is having the minimum elevation in the boiling point, so we have to search for which is having minimum delta TB value. That will give you the answer. Minimum delta TB means I have to search for minimum M into I product. M into I product. So we know that molality is not given, it is given as molarity. We can roughly take it as molarity. So we can say it is 0.1 multiplied by I factor for urea is 1 because it is not dissociating. So this is equal to 0.1. So we want minimum M into I product. So here it will be 0.1 multiplied by, assuming 100% dissociation, 1 mole of NaCl dissociates to give you 2 moles. So the Van't Hoff factor is 2. So this will be equal to 0.1 into 2, that is equal to 0.2. M into I product is 0.2. Here you know that it is 0.1 multiplied by 1 mole of MgCl2 will produce 3 moles of the total number of particles, that is 1 Mg2 plus and 2 Cl minus. So 0.1 into 3. This is 0.3. Now if I go for aluminium sulfate, 0.1 multiplied by Van't Hoff factor for this will be Al2SO4 thrice dissociates to give you 2Al3 plus 3SO4 2 minus, total number of particles produced is 5. So this is coming out as 0.5. Now we have to search for minimum M into I product. So the minimum M into I product comes in the case of 0.1 molar urea, that is 0.1. So the answer for the given question is, it is equal to 0.1 molar. So option A is the answer. Option A is the answer. Is it clear, students? Just have a note of this. Shall we go for the next question, students? Look into question number 6. Four gram of a non-volatile solute dissolved in 36 gram water. So we can say that W2 given here is equal to 4 grams, is dissolved in 36 grams of water. W1 is equal to 36. W1 is equal to 36. The relative lowering of vapor pressure is said to be 0.1. relative lowering of vapor pressure is nothing but delta P divided by P1 naught. Delta P is nothing but P1 naught minus P1 divided by P1 naught, that is given as 0.1. Then they're asking what is the molecular mass of the solute. M2 is a question mark. So now we know that we have a formula delta P divided by P1 naught, this is equal to W2 into M1 divided by M2 into W1. Let us substitute. Delta P by P1 naught is given as 0.1. You should know that delta P is equal to P1 naught minus P1. So 0.1, that is equal to W2 is given as 4 gram multiplied by molar mass of water has to be known. This is used as solvent. Molar mass of water will be equal to 18 gram per mole, will be equal to 18 gram per mole. So I have to substitute this as 18 divided by M2 has to be calculated. M2 multiplied by W1 is given in the problem as 13. So now I can say that, which implies that M2 will be equal to 4 into 18 divided by 0.1 into 36. 18 1 times, 18 2 times, 2 1 times, 2 2 times. So ultimately what we get is 2 divided by 0.1. This should be equal to 20 gram per mole. 20 gram per mole. So what is the answer? Option B should be the answer. So what is the answer, students? Option B. Option B is the answer. Just note it down, students. Is it clear? Okay. We shall look into question number 7. Question number 7 given is a 6% solution of urea is isotonic with. So now let us know what is 6% solution. 6% solution means 6 gram implies 6 gram of urea is dissolved in sufficient solvent so that 100 ml of solution is present. 100 ml of solution is present. I think this point is clear, students. Now let us calculate what will be the value of pi. Pi will be equal to pi of urea will be equal to let us say concentration, you know, CRT. This is the basic formula that you need to remember for this question. Pi is equal to CRT, where C is said to be the molar concentration. Molar concentration is nothing but number of moles of urea will be 6 divided by 60, since the molar mass of urea is 60 gram per mole. I think this is clear, students. Now you know that pi is equal to C into R into T. So C, number of moles, 6 by 60 divided by volume of the solution in liters, 100 ml. You know that 100 ml, this should be equal to 0.1 liter. So divided by 0.1. So you can clearly say that into R into T. So this should be equal to, this is 1 times, this is 10 times. So this should be equal to RT. And I need to include the Van't Hoff factor, and you know that Van't Hoff factor will be equal to 1. So therefore this will be equal to RT. Pi of urea is equal to RT. Is it clear, students? Now we need to check which of these will be having pi as RT. It is very clear that if I go for option number D, pi of glucose is equal to, we know molarity is already given, C is already given as 1 into R into T into, you know what is the Van't Hoff factor for glucose, since it is a non-electrolyte, it should be equal to into 1. So therefore this would be equal to RT. So you can see 6% urea is isotonic with 1 molar solution of glucose. So therefore answer should be 1 molar solution of glucose. Option D is the answer. So option D is the answer. Now let's check what would be the value of pi for option 1, 2, that is A, B, C. Check it, students. What would be the value? I told you the answer. Now tell me what is the value of pi for the first option. Pi for the first option will be equal to C is given 0.05 into RT into 1, because glucose is non-dissociating. So therefore this will be equal to 0.05 RT, which is not equal to RT. What is the answer for the second option? 6% solution. So pi will be equal to, what is 6%, meaning 6 divided by molar mass of that present in 100 ml, so that is 0.1. So now you can definitely say that this will be equal to, into RT is definitely present, into 1. So you know that 6 ones are 630 times, so this should be equal to 1 by 3 RT into 1, so which is definitely not equal to this RT. And option C, obviously you can check. So 25% means what? Pi will be equal to 25 divided by 180, and this is multiplied by 0.1. So definitely you can understand this would come out as 1 divided by, I can call it as 5 5 and I can call this as 36 times. So I can say that this will be equal to 5 by 36 into 0.1. 5 by 36 into 0.1 is 5 by 3.6 into 5 by 3.6. Is it clear? 36 into 0.1 is 3.6. So 5 by 3.6 into RT. 5 by 3.6 into RT. So you can clearly understand this is 5 5s are 25, 5 3s are 15, yes 36. 5 by 36 into 0.1, that is nothing but 5 by 3.6 into RT, so which is definitely not equal to RT. So therefore option D is only the answer, which we already discussed here. This is for option D. So which option is the answer? Option D is the answer. Okay students, shall we go for the next question? Question number 8. Question number 8. Question number 8. We shall go for question number 8. In countries near to polar region, the roads are sprinkled with calcium chloride. This is because, definitely this is a nonsense statement to minimize pollution, to minimize the accumulation of dust on the road, no. To minimize the wear and tear of the road, no. So in polar regions there would be snow standing on the road, so which would make the road very slippery. Just to melt that snow, so we will be adding calcium chloride. So the principle is delta TF is equal to KF into M into I. So option A is the answer. Option 1 is the answer. Is it clear, students? Shall we go for the next question? 0.02 molar aqueous solution, 0.02 molar aqueous solution of an ionic compound, freezes at minus 0.073 of an ionic compound, CONH3 5 times NO2 Cl, freezes at minus 0.0732 degrees Celsius. It means that we know what is TF naught for water, 0 degrees Celsius. What is TF? They have given minus 0.0732. Therefore, delta TF will be equal to TF naught minus TF. This will be equal to 0 minus of minus 0.0732 is 0.0732. This is the value of delta TF given. And also they have given what is molality. Molality is equal to 0.02. Number of moles of ions produced by 1 mole of the ionic compound produced in number of moles of ions which 1 mole of ionic compound produced thus in water will be. Kf value is given. Kf value is equal to 1.86. Indirectly what they are asking is what is the value of I? What is the value of the Van't Hoff factor? We know that delta TF is equal to Kf into M into I. Now I will be equal to delta TF divided by Kf into M. This will be equal to delta TF value is given as 0.0732 divided by Kf value is given, it is 1.86 multiplied by molality of the solution is also given, it is 0.02. Now you can solve this, so you can write this as 7.32 into 10 to the power of minus 2 divided by 1.86 into 2 into 10 to the power of minus 2. So now you can solve for this. 10 to the power minus 2, 10 to the power minus 2 cancels. So you can easily know what is 1.86 into 2. What is 1.86 into 2? So this will be equal to 2 6 are 12. I'll write as 1.86 into 2. That will be equal to 6 are 12. 1. 2 8s are 16 plus 1 17. So 1. 2 1s are 2. So plus 1 3. So this is equal to 1.68 into is 3.72. So this is approximately 1 times and this is 2 times, approximately closely. 3.72 into 2 will be equal to approximately to nearly closer to 2, it is 1.968. so this will be approximately equal to 2. So the answer should be, it produces how many ions? 2 ions. So what is the answer, students? Option 2B is the answer. Is it clear, students? Next question, question number 10. Just look into question number 10, students. A binary liquid solution is prepared by mixing N-heptane and ethanol. N-heptane and ethanol. You know that between ethanol molecules there would be intermolecular hydrogen bonding, and in N-heptane there is no hydrogen bonding. When you add N-heptane to ethanol, the hydrogen bonding between ethanol is broken. Definitely interaction between ethanol and N-heptane would be less than between ethanol and ethanol. So easily you can understand it is an example for positively deviating solution. So therefore this solution is non-ideal, showing positive deviation from Revolt's law. So what is the answer, students? Option B. So answer is option B. Yes, question number 11. Just look into question number 11. Now, a solution of sucrose has been prepared by dissolving 68.5 grams. W2 is given as 68.5 in 1000 grams of water. So W1 is equal to 1000 grams, that is equal to 1 kg. The freezing point of the solution will be, they are asking what will be TF is equal to question mark. We know that Tf naught is equal to 0 degree Celsius. Now students, first we should know what is the formula of sucrose. Formula of sucrose is C12H22O11. This should be equal to 12 into 12, that is 144, plus this is 22 into 1, plus, you know what is the atomic 11 oxygen atoms are present. What is the atomic mass of oxygen? It is 16. So this will be 11 into 16 is nothing but equal to 16 tens are 160, and it should be equal to 176. So 176 plus 22 plus 144 comes out to be 342 gram per mole. That is a molar mass of sucrose. Okay. Now we know that first we have to calculate delta TF. Delta TF is equal to KF into W2 into 1000 divided by M2 into W1. Substituting all the values, you can get it as KF value for water is given as 1.86 multiplied by W2 value is given as 68.5 into 1000 divided by, so M2 value is known, we have determined, now we have calculated, it is 342 multiplied by W1 is given as 1000 grams. It is given as 1000 grams. Now roughly you can say that 68.5, 1 times this is 5 times, so therefore you can say this 1000 and this 1000 cancels. So what will be delta TF? That will be equal to 1.8586 multiplied by 1 by 5 is 0.2. 1.86 multiplied by 0.2. I think this is clear, students. This is equal to 0.372. This is equal to, you can take it as 18.6 into 2. So 18.6 into 2 is nothing but 37.2. So adjusting the points, it comes out to be 0.372. So you got what is the value of delta TF. We know that delta TF is equal to TF naught minus TF. We know what is delta TF, 0.372. We know what is said to be TF naught, that is 0, minus TF implies TF will be equal to minus 0.372. So which answer? Option D should be the answer. So question number 11, option D is the answer. I'll write here option D. Option D is the answer. Is it clear, students? So what did we do? First we calculated delta TF, then we have used the formula delta TF is equal to TF naught minus TF. Shall we go for the next question, students? Question number 12. A solution of 2 liquid boils at a temperature more than the boiling point of either of the solution. If the boiling point is more, what should be the kind of deviation? If the boiling point of the solution is more, what should be the kind of deviation shown by it? So we have seen it. If the boiling point becomes to be more, then what should happen to its volatility? It should be less. What should happen to the vapor pressure? It has to be less. So if the total pressure would be less than expected, then it should be showing what kind of deviation? Negative deviation. So therefore, for question number 12, what should be the answer? It shows a negative deviation from Raoult's law. So what is the answer, students? It shows negative deviation. So option B is the answer for question number 12. Okay. Question number 13. After adding non-volatile solute, freezing point of water decreases to minus 0.186 degrees Celsius. It means that delta TF is equal to TF naught minus TF. So delta TF should be equal to 0 degrees the boiling point of water, freezing point of water, minus, so you know that it is given as minus 0 0.186. So delta TF is equal to plus 0.186 degrees Celsius. I think this is clear, students. You have to calculate delta TB. You have to calculate delta TB. Delta TB is a question mark. But what they have given is KF. So KF value will be equal to, KF value is given, that is equal to 1.86 Kelvin kg per mole. So they have given you the KB value. KB value is equal to 0.521 Kelvin kg per mole. Now students, we know that delta TF is equal to KF into M into I. We don't know whether it is said to be an electrolyte or non-electrolyte, so I am including the Van 't Hoff factor. So now we can calculate what is M into I. M into I is nothing but equal to delta TF divided by KF. What is delta TF value? We got it as 0.186 divided by, what is KF value? It is 1.86. So I can write this as, this is equal to 10 to the power of minus 1. This is equal to 10 to the power of minus 1. Is it clear, students? Now, once if I get the value of M into I can use this formula here. Delta TB should be equal to KB multiplied by M into I. Since the same electrolyte is being used or same solute is being used, I know what is M into I. So we can definitely calculate what is delta TB. So delta TB will be equal to, KB value is given as 0.521 multiplied by M into I product. You can see it is 10 to the power of minus 1 into 10 to the power minus 1. So therefore delta TB will be equal to 0.0521. What is delta TB value? 0.0521 degrees Celsius. So which is the answer, students, for question number 13? 0.0521 is there in option B. So answer is option B. Shall we go for the next question, students? Question number 14. Question number 14. We need to know osmotic pressure. We need to know osmotic pressure of the solution can be increased by. So yesterday have seen pi is directly proportional to C. Pi is directly proportional to T. And we have combined this and we wrote pi is directly proportional to C into T, and finally we wrote pi is equal to C into R into T, where R is a universal gas constant. Now osmotic pressure of a solution can be increased by increasing the concentration. So increasing the temperature. Increasing the temperature of the solution is given, so this fits into the answer. Decreasing the temperature cannot be. Increasing the volume of the container, you know that for solution, so if you increase the volume there is no much changes. Diluting the solution, so if you dilute the solution you can clearly understand, so pi is directly proportional to C, so therefore you can clearly understand. So if concentration is decreased, upon dilution concentration decreases, osmotic pressure decreases. So what is the correct answer, students? It should be A option. So answer is option A. Option A is the answer. Is it clear, students? Just look into it. We actually call pi directly proportional to C as Van 't Hoff Boyle's law, and pi directly proportional to T is known as Van 't Hoff Charles law, and the combined form. So it is not mentioned in the NCERT as Boyle's law, Van 't Hoff Boyle's law and Charles law. So in my class I did not mention it as Boyle's law and Charles law, but I have mentioned these mathematical expressions. Let us go for the next question. 18 gram of glucose is added to 17.8 gram of water, full stop. The vapor pressure of water in torr for the aqueous solution is. Now we know that This question is related to relative lowering of vapor pressure, and one thing we need to assume that is what is the vapor pressure of water at 100 degrees Celsius. It is not mentioned as 100, we need to consider it as 100 or else you cannot solve the problem. Now let us write P1 naught minus P1 divided by P1 naught, that is equal to W2 into M1 divided by M2 into W1. Now let us start substituting. P1 naught at 100 degrees Celsius for water is 760 millimeter of mercury. We need to calculate what is the value of P1, and P1 naught value is given as 760. That should be equal to, you know what is the mass of solute dissolved, that is 18 grams, multiplied by M1 is said to be the mass of solvent that we have dissolved, that is 178.2, divided by what is M2, molar mass of the solute, that is 180, that is for glucose, molar mass of glucose, multiplied by what is W1, it is, sorry students, this is 18, M1 is a molar mass, 18, divided by this is 178.2. So this should be equal to 18. I think this is clear, students. Now we have to solve for this so as to get the answer. Now let us solve it easily. See, approximately this can be taken as 180. So closely 1 times, this is 10 times. Is it clear? This is 1 times, this is also 10 times. This is approximated value. 18 1 times, 18, 10 times is 180. This is approximated as 180. So we don't have to solve exactly because answers are very far away, you can see. So we can do all sort of approximation. 7.6, 76, 752.4 and 759 are very large value differences. So you can go for this approximation. Now this 100 means I can say that I can shift the decimal points here. So I can write it as 7.6 times. Implies 760 minus P1 is equal to 7.6 implies P1 is equal to 760 minus 7.6. So this P1 now will be equal to 760 minus 7.6 is 752.4 millimeter mercury, or this is also called as torr. One very important thing that you need to know is P1 naught of water. This is at 100 degrees Celsius. This is equal to 760 millimeter of mercury, or torr. Unless you know this, unless you assume that this is at 100 degrees Celsius, you cannot solve this problem. So it is answer for the given question, students. It should be equal to 752.4. So answer for this question is option C. Option C. So question number 15 has the answer as option C. Is it clear, students? We shall go for the next question. You can note it down. You finish noting down, students? Okay, we shall go for the next question. Question number 16. Question number 16. Which of the following statement about the composition of the vapor phase over an ideal 1:1 molar mixture of benzene and toluene is correct? Assume that the temperature is constant at 25 degrees Celsius. Given vapor pressure data at 25 degrees Celsius, benzene is 12.8 kilopascal and toluene is 3.85 kilopascal. Students, now you know that the one which is having the higher vapor pressure, which implies that is more volatile, is more volatile. Is it clear, students? Okay. Now, you know from Raoult's law that P1 is equal to P1 naught x1. If it is more volatile, P1 naught would be more, that is vapor pressure of the pure solvent would be more. And let me say this 1 is equal to, for benzene, P2 is equal to P2 naught x2, and we know we shall take this 2 as Tolvin C6H5CH3. Okay. They said that 1:1 molar ratio, 1:1 molar mixture means mole fraction of 1 will be equal to 1/2 and mole fraction of 2 will be equal to 1/2. I think this point is clear, students. We know that they are asking what, assuming that the temperature is constant, which of the following statement would be correct? Everything is given in terms of the vapor pressure. Now we can say that vapor phase composition Yi is equal to Pi naught Xi divided by P total. P total is constant for both. If we write it for Y1 and Y2, it would be same. So total vapor pressure would remain same over the solution. X is also constant, that is half and half, since it is in the ratio of 1:1. So therefore Yi is directly proportional to, this is Pi naught, is directly proportional to Pi naught. So higher the vapor pressure of the pure solvent, higher would be its composition in the vapor phase. So now you can see higher vapor pressure is there for benzene, so vapor phase composition would be more of that of benzene. So first option, the vapor will contain equal amounts of benzene and toluene. Definitely no, because its vapor pressure is said to be more. Not enough information is given to make a prediction. No, information would be sufficient. The vapor would contain a higher percentage of benzene. Definitely this should be the answer, because Y is directly proportional to Pi naught. So vapor pressure of pure benzene is more, therefore its composition in the vapor phase would be definitely more. So what is the answer for the question number 16, students? Option C is the answer. I think you got the key point. Higher the vapor pressure of the pure substance, higher would be the vapor phase composition. So benzene has higher vapor pressure of 12.8 Pascal kilopascal than 3.85, that is of toluene. So therefore the one which has the higher vapor pressure, that would have the higher composition in the vapor phase. More volatile component would easily escape into the gaseous state, and its mole fraction would be high, its composition would be high. I think this point is clear, students. Shall we go for the next question? Question number 17. Question number 17. At 100 degrees Celsius, the vapor pressure of a solution of 6.5 gram. So therefore they have given what is W2. W2 is equal to 6.5 grams. Dissolved in 100 grams of water, 100 gram of water. The vapor pressure of that P1 is given as 732 millimeter of mercury. Kb value is given. Kb is equal to 0.52 Kelvin kg per mole. The boiling point of this solution will be how much? So since it is 100 degree, you should know what is P1 naught. P1 naught is equal to 760 millimeter mercury. So what we need to calculate, what will be the boiling point of this solution? TB is equal to question mark. Now you need to connect between the two colligative properties. two colligative properties. One is said to be, we can't directly find what is TB, we need to find what is delta TB. So then from that we can calculate what is said to be the TB value. First, from the given data we can calculate the molar mass of the solute. So we can use this formula, P1 naught minus P1 divided by P1 naught, that is equal to W2 multiplied by M1 divided by M2 into W1. So substituting all the values, P1 naught is known as 760 minus 732 divided by P1 naught is 760, that is equal to W2 is 6.5 multiplied by, and M1 is said to be 18 divided by M2, molar mass of the solute we shall calculate, multiplied by, you know that W1 is 100, this is equal to 100, implies M2 will be equal to 6.8 into 118 multiplied by 760 divided by, so you know that 100 multiplied by 760 minus 732 is nothing but equal to, it is 28. The value of that will be equal to 28. Let us not solve it here. So we shall use this formula now. Delta TB that will be equal to KB into W2 into 1000 divided by M2 into W1. This should be equal to, KB value is known, it is since it is to be given as 0.52, so it is given here in the problem as 0.52, we'll write as 0.52 into W2 is 6.5 multiplied by 1000 divided by M2 value we should substitute, W1 value is known as 100 multiplied by, you know that in the denominator I should substitute the value of M2. M2 is nothing but 6.8 into 18 into 760 divided by this 100 goes above into, this is 28. So now lot of number cancels out each other, so method of calculation becomes easier. You know that this 100 cancels, this is 6.8, 6.8, this is 6.5, this is 6.5, sorry, this should be 6.5. So this 6.5 and this 6.5 cancels, and you can easily cancel out certain other numbers. I can write this as 5.2 into 10 to the power minus 1 into 10 to the power of 3 into 2.8 multiplied by 10 to the power of plus 1 divided by, I can write this as 18 as 1.8 into 10 to the power of plus 1 multiplied by 7.6 multiplied by 10 to the power of 2, 10 to the power of 2. So you can easily cancel certain numbers. So we can see that this 10 to the power of plus 1 cancels, this 10 to the power of minus 1 and this 10 to the power of plus 3 becomes to be 10 to the power of 2, this 10 to the power of 2 cancels. Ultimately we are remaining with 5.2 into 2.8, 5.2 into 2.8. You can calculate what is that, 5.2 into 2.8. So 5.2 into 2.8 comes out to be 14.5, 14.5 divided by, so you have 1.8 into 7.6. this is 8, this is 6, this is 3, this is what, this is 13.68, this is 13.68. Approximately you can take it as 14.5 divided by 13.6 is nearly equal to 1. So delta TB comes out to be nearly equal to 1. Delta TB is nearly equal to 1. So just calculate it, students. You can check delta TB will be nearly equal to how much? 14.5. You can solve for that. 14.5 divided by 13.68. You're not supposed to use the calculator, students. So closely you can take it as 1. Why do you take it as 1, students? You can see this is not definitely equal to 2. It is not double. 14.5 is not double of 13.6. It is not definitely equal to 0. It cannot be. It is not definitely equal to 3 times. So therefore the answer will be closer by 101 degree. No. So delta TB is equal to how much? That is coming out as 1. So therefore delta TB is equal to TB minus TB naught. So you know this is 1. This is equal to we don't know TB minus this is 100 degrees Celsius, which implies that delta TB will be equal to 101 degree Celsius. So here I'll write, we know that delta TB is equal to TB minus TB naught. This is 1. This is equal to TB minus this is said to be 100 degrees Celsius, implies TB will be equal to 101 degrees Celsius. So answer is 101 degree Celsius. I think this point is clear, students. So what is the answer for the given question? It is option C. Option C is the answer. Is it clear? Just note it down, students. Okay, question number 18. Which one of the following is incorrect? Incorrect. This is important. Many times we'll forget to read it as incorrect. We'll read it as correct. Incorrect for ideal solution. You know that for an ideal solution, delta P is equal to 0. Since mixing is a spontaneous process, whether it is ideal or non-ideal, delta G should be negative. It is not equal to 0. So therefore option B is the answer. Option B is the answer. Delta H mix is equal to 0. You know there is a characteristic. Delta U mix is also equal to 0. We shall go for the next question. Question number 19. The Van't Hoff factor I for a dilute aqueous solution of the strong electrolyte would be, you know that barium hydroxide is said to be a strong electrolyte, BaOH twice plus 2OH minus. So 1 mole of this would dissociate to give you 1 plus 2 moles of this. So therefore I factor will be equal to 3 by 1, that is equal to 3. So it is answer, students, option B. So answer for the question number 19 is option B. Is it clear, students? Just note it down. Shall we go for the next question, students? Assertion: when a solution is separated from the pure solvent by a semi-permeable membrane, the solvent molecules passes through it from pure solvent side to the solution side. So definitely, so when there is a semi-permeable membrane, so it should be osmosis. So the statement is regarding osmosis. Whether this statement is correct? Definitely this statement is correct. Reason: diffusion of solvent occurs. Diffusion is not through semi-permeable membrane, it is simply passing of the substance. So diffusion of a solvent occurs from a region of high concentration solution to the region of low concentration solution. Definitely this statement is also correct, but the reason given for osmosis is not correct. So therefore both assertion and reason are correct. Both assertion and reason are correct statements, but reason is not the correct explanation. Then what is the correct explanation? So correct explanation would be due to the difference in the vapor pressure, the movement of solid molecules takes place from a region of low concentration to the high concentration side through semi-permeable membrane. Due to the difference in the vapor pressure, there would be osmosis. But here the second statement is regarding diffusion. So this statement is correct, but it is not the correct assertion, is not the correct reason for the given assertion. So option B is the answer. So it is the answer, students, option B. So we have finished the chapter of solutions. Once again, we have finished it, students. All level 1 question is also over. Just work out on all previous year examination questions so that working out will be easy for you. Now let me give you the list of formulas that you need to remember from the chapter of solutions for the annual examination. So important formula list, let me write it here. Important formulas, formula list that you need to remember from the chapter of solutions. Let me start writing the formula list. First one, you need to remember the formula of mole fraction of two components. I'll give mole fraction of A will be equal to number of moles of A divided by total number of moles. I'll write as NT. Similarly, so mole fraction of B will be equal to number of moles of B divided by total number of moles present in the solution. And also you need to remember that sum of mole fraction of all the components, I'll write as sum of mole fraction of all the components should be equal to 1. It should be equal to 1. Then is it clear, students? Now xt should be equal to 1. Now second one that we are studying that we have studied is that molality, that is equal to number of moles of solute divided by number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. Is it clear, students? Then the third one is that molarity is equal to number of moles of solute divided by volume of solution in liters. Fourth formula that we have studied was for mass percentage. M by M percent is equal to that is equal to mass of solute divided by mass of solution whole multiplied by 100. And the next formula that we have studied was fifth one. Let me write it here. Parts per million. This is equal to parts of solute parts of solute divided by parts of solution whole multiplied by 100, sorry, 10 to the power of 6, whole multiplied by 10 to the power of 6, 10 to the power of 6. And we have studied mass by volume percent. Mass by volume percent is equal to mass of solute divided by mass of solute divided by volume of solution. Usually this has to be expressed in ml and this has to be expressed in grams multiplied by 100. So these are the important things that you need to remember from the first part. Then after that we have studied P is equal to, partial pressure is equal to KH multiplied by X. So where X is the mole fraction of the solute in the solution, and P is said to be the partial pressure of the gas over the surface of the solvent of the solution or liquid. KH is called as Henry's law constant. Then P1 is equal to P1 naught X1 P2. Generally I can write this as Pi is equal to Xi into Pi naught. Then we have studied the 9th formula for a binary solution applying Raoult's law. P total is equal to, I can write as P1 naught plus P2 naught minus P1 naught into X2. Then vapor phase composition Yi is equal to Pi naught Xi divided by P total. So then the 11th formula that we have studied was RLVP, P1 naught minus P1 divided by P1 naught, that is equal to W2 into M1 divided by M2 into W1. So usually for the board examination we don't use the Van't Hoff factor, so it is always equal to 1. Electrolytes will not be given. Then let me give you the next formula. 12th formula that you have studied was delta TB is equal to KB into W2 into 1000 divided by M2 into W1, M2 into W1. And another formula that we have studied, 13th formula, delta TB, that is equal to TB minus TB naught. 14th formula that you need to remember is delta TF is equal to KF into W2 into 1000 divided by M2 into W1. And 15th formula that you need to remember is delta TF is equal to TF naught minus TF. Question number 16 that you need to study is that pi is equal to CRT, and that should be equal to N2 by V into RT. That should be equal to W2 into RT divided by M2 into V. So these are the set of formulas that you need to remember. 17th formula that you need to remember is that I is equal to normal molar mass divided by abnormal molar mass. This is equal to observed colligative property divided by calculated colligative property. That is equal to number of moles of particle. Let me erase this. That is equal to number of moles of particle after, P stands for particle after, dissociation or association. D stands for dissociation, A stands for association, divided by number of moles of particles before dissociation or association. These are the three important formulas for finding out the colligative properties. Formula number 18 that you need to remember is degree of dissociation alpha D is equal to I minus 1 divided by n minus 1. Formula number 19 that you need to remember is alpha of association is equal to I minus 1 divided by 1 by n minus 1. And 20th point that you need to remember is if I is greater than 1, I is less than 1. So if I is equal to 1, here no dissociation or association. Here if I is less than 1, so solute associates, and if I is greater than 1, solute dissociates. So these are important points that you need to remember. So I think if you remember these 20 points, students, most of the concepts of solution would be over. So please note down the list of formulas, students. So I think you have noted down all these things. So already we have written it. If you know this, it would be always helpful. And few important tips for your competitive examination level 1, since it was there. So I'll tell you 1 or 2 points. So usually for your board examination, one question in question number 28, A will be a numerical from colligative properties, So you should know that any of the colligative properties is inversely proportional to molar mass of the solute. This is another important point you need to remember. One question from colligative property would be definitely asked, students, that is RLVP. I'll write it here, RLVP, or delta TB, or delta TF, or pi, based on the calculation of molar mass. So if you study whatever I have done in my class, definitely you can score 7 out of 70. 10% of your marks will be from this chapter. If you're aiming to score 70 out of 70 in the annual examination, never leave this chapter, because question number 1 and 2 is section A, where you don't have choice. 2 questions will be from this chapter, that is question number 1 and 2, each carrying 1 mark. I think all these points are clear, students. We shall start with the next chapter, that is surface chemistry. I'm starting the new chapter, students, that is surface chemistry. Very simple chapter, no numericals, only theory based. It is said to be one of the easiest chapter. Theory, no problems. So there is only theory in this. Now As I always start the new chapter by telling the chapter weightage, let me tell you what is the chapter weightage given for this in the annual examination. Chapter weightage is equal to 1 mark question. One mark question would be asked in the annual examination, students, plus 1 5-mark question. So this will be equal to totally 6 marks. 6 marks out of 70 can be easily scored. Since there is 1 mark, you cannot skip this chapter for the annual examination. You need to study. It looks like a boring chapter, but it's not boring. So it is only theory based. Always any student would like to study this chapter. Then usually the question numbers in your question paper would not be changed. So you know that question number 1 and 2 is from solutions. Question number 1 in the annual examination will be from solutions. Question number 2 will be from solutions. Question number 2 is also from solutions. Question number 3 will be from electrochemistry. Question number 4 in the annual examination question paper will be from chemical kinetics. Already these all chapters are over for you, from chemical kinetics. Question number 5, which is a 1-mark question, which comes from surface chemistry. I think all these points are clear to you, students. So this will be from surface chemistry. So you cannot leave this chapter. This question number 5 will be, this is all in part A. So physical chemistry, you know, it is part D. So Roman number 4, you will be having 5 questions, out of which you need to answer 3. You will be having 5 questions, you need to answer 3. So out of 5 you need to answer only 3. 5 questions would be there, 3 you need to answer. So each question will carry 5 marks, so total marks will be 15. So you have 2 extra questions here. So 3 you need to answer out of 5. So question number 27, question number 28, question number 29, question number 30. This is the last chapter in the physical chemistry that you are studying. This is from solid state. This will be from solution chapter, as I told you earlier, solution chapter, question number 28. Question number 29 will be from electrochemistry. Question number 30 will be from chemical kinetics. And question number 31 will be from surface chemistry. Usually this question number 31 would be split into A, B and C. So in this chapter we are going to study 3 parts. First part would be based on adsorption. Second part that we are going to study is from catalysis. And the third part that we are going to study is about colloids. So we can't say what mark is allotted. Usually colloids will be allotted with 2 marks. So here either this will be 2 or 1. Here it will be 2 or 1. If this is 2, it will be 1. If this is 1, this will be 2. So total marks for this chapter will be equal to 5 plus 1, 6 marks. Now let us go for the beginning of the chapter. So let us start from the first part of this chapter, that is adsorption. Let us study something about the concept of adsorption. Okay. So we shall study something about the surface chemistry. As I told you, it is divided into how many parts, students? It is divided into 3 parts. So the 3 parts are, first part that we are going to study is adsorption. adsorption. The second part of this chapter that we are going to study is catalysis. And the third part of this chapter that we are going to study is about colloidal system, colloids. We are going to study about colloids. First we shall study about this adsorption, then later we shall study about this catalysis and colloids. Now, first we shall see what is adsorption. So I'll teach you this concept with some examples, so you can look into those examples and you can understand what is the concept of adsorption. Let us say that we have a sponge. Let us say that we have a sponge. Let me say that this is a small piece of sponge. We are putting this into water. Let me say this is said to be water. Let me say it is put into water. Now, if I put this sponge into water, tell me students, what will happen? This is water. This is sponge. When you put a sponge into water, so the sponge molecules would be accommodating the water, and water enters into the bulk. Water enters into the bulk. Water goes into the bulk. It will be on the surface also. And this kind of thing is called as what? This is called as absorption. absorption. This is called as absorption. Is this clear, students? So one substance, that is water, enters into the bulk of the another substance, that is sponge. So here we have two things. So which are the two things? The substance that enters and the substance which allows to enter into the bulk. So such a phenomenon is called as what? We call it as absorption. So what is absorption? It is a phenomenon in which one of the substance enters into another substance. One of the substance enters into another substance and gets uniformly distributed throughout the bulk. What do we call this concept as? We call this as absorption. Now, examples, some other examples for absorption. Suppose if you dip biscuit, if you dip biscuit into tea. Tell me, students, whether this tea enters into the bulk of biscuit. Definitely. So then we should call this as an example for what? Adsorption. You can also give the example of gulab jamun. You can also give the example of chalk dipped in water. You can also give this example. Chalk is dipped in water. Now, the substance which is being absorbed. Now tell me, in this example of sponge and water, which is being absorbed. So the substance that is being absorbed is water. And we call such a substance as which is being absorbed as absorbate. It is called as absorbate. I think this point is clear, students. What is an absorbate? The substance which is getting absorbed into the bulk of a substance is called as absorbate. Now, which is giving the scope for that absorption? That is nothing but sponge. So water is said to be absorbate. Then what should be this sponge called as? So this sponge should be called as adsorbent. It is called as absorbent. It is called as an absorbent. So now what we have studied, when a sponge is dipped into water, water penetrates into the bulk of this sponge and it gets uniformly distributed, and we call this concept as what? Absorption. The phenomenon in which one of the substance penetrates into bulk of the another substance and it gets absorbed is called as what? Absorption. The substance which gets absorbed, here in this case it is water. Water is called as absorbate and sponge is called as absorbent. Is it clear, students? Now, let me give you another example. Now say that to explain all these concepts, I have written on a piece of a small whiteboard. Now can you tell me, A teacher who writes on the whiteboard or on the blackboard is an example for absorption. Do you say it is absorption? Can it be absorption, students? Whether the marker ink, whatever I have written, does it goes into the bulk of the board or does it accumulates only on the surface of the board? What is the answer? It is accumulated only on the surface of the board, so it is not penetrating into the bulk. And such kind of phenomenon which is happening only on the surface, accumulation of one of the substance that takes place on the surface only, and we call this phenomenon as absorption. Here I should call it as adsorption. What should I call it as, students? Adsorption. So I think you got the point. What is adsorption? So suppose if I say that I'm writing using marker ink, I'm writing using marker on whiteboard, Now you know that the one which is getting adsorbed, is marker ink, is getting adsorbed, and we call this as what? As we have seen, absorbent and absorbate. So this is called as what? So a chalk or a teacher is writing on the board, and what do we call this as? Adsorption. So here also you know that we can say that chalk is getting adsorbed, or here I can call it as marker ink is getting adsorbed. So the one which is getting adsorbed is called as what? Adsorbent. This is called as adsorbent. The one which is giving scope for adsorption, this is called as what? Adsorbate. This is called as adsorbate. Is it clear, students? So what is said to be adsorbent and what is said to be adsorbate? The one which is getting accumulated and the one which allows that. So what is it called as? The substance which is being adsorbed. Here it is marker ink, that is called as adsorbent. The one which is giving scope for adsorption, that is called as what? Adsorbate. So you can see when any new electrical items are taken, so you can see a packet, a small packet would be present where they would write it as silica gel. So this is also an example for adsorbing substance. So you can write a lot of such examples. Now let us see what is the reason for this adsorption. So you can look into your study material for the definition of adsorption. So for the definition of adsorbent, for the definition of adsorbate, so you need to remember those definitions, students. It can be asked in the examination for 2 marks. Just go for your study material. Just go for your study material, students. Go for page number, just go for page number 97. Mark it. So definition of adsorption, definition of adsorbent, definition of adsorbate. What is the definition of adsorption, student? Just read it. So the definition, you can mark it as important. You can mark it as important. So you can say this definition, students. So adsorption is a phenomena where there is preferential accumulation of a gaseous or a liquid on the surface of a solid rather than in the bulk of the medium. Mark it as important. Second one, adsorbent. Adsorbent is a solid substance on the surface of which a gas or a liquid can be accommodated, can be adsorbed. Adsorbate. Adsorbate is a substance which gets absorbed and accumulates on the surface of a solid. Adsorbent. Already have given you certain examples. So certain other examples you can also say that when chlorine gas is taken in a closed vessel, when chlorine gas, Cl2 gas, so is taken in a closed vessel which is added with some powdered charcoal, powdered charcoal, the pressure of Cl2 gas decreases. That is only because of adsorption. So on the surface of charcoal, chlorine gas is being adsorbed. So this is an example for adsorption of a gas, adsorption of a gas on solid surface, adsorption of a gas on a solid surface. I think this point is clear, students. Now if I also take the example of another container where I have taken acetic acid liquid, CH3COH liquid. So now I am adding some amount of powdered charcoal. Concentration of acetic acid decreases. Concentration of acetic acid decreases. It means that powdered charcoal has absorbed some amount of acetic acid on its surface and hence the concentration decreases. So this will be an example for a liquid getting adsorbed on the surface of a solid. In the first part of the chapter adsorption, we are going to study only about the adsorption of gases. I think this point is clear today. So the definition of adsorption can be asked. So just look into page number 97 in your study material, students. Mark it. Adsorption is a phenomenon where a liquid or a gas penetrates into the body. Absorption definition: absorption is a phenomenon where a gas or a liquid penetrates into the body of the absorbent and gets uniformly distributed in which the whole body of the adsorbent, So example given for that, you can see in the material: sponge absorbs water when dipped into it, anhydrous calcium chloride absorbs water. Now let us see what is the reason for this adsorption. Let us see what is the reason for this adsorption. Students, now let us say that we have one minute, students. So it has gone into the portrait mode. I'll change the option. One minute, students. You correct one there. 1 minute, students. ಎಂತ ಕರ್ಮ ಇದು ಸರಿ ಮಾಡಿ One minute, students. I'll start. I need to change the orientation of this. One minute, students. So by the time you read the definitions. Hello. Oh. Okay, sir. Okay. Okay, sir. Okay, students, now let's go for the next part. Okay, students, let us see what is the reason for adsorption now. Hello. Okay, I'll keep on material, sir. 1 minute. Is it looking properly, sir, now? Hello. Oh, it has. Should I rate the phone once again, sir?
Make sure the phone should not discount.
Okay, okay, sir. Yes, students, we shall continue because of the interruptions, so that it has gone into the portrait mode. So let me go back and let me start continuing that. So I was telling you something about how can we explain the phenomenon of adsorption, why adsorption takes place, why adsorption takes place. See, if you consider a bulk of the substance, let me say that for easy to understand, let me say that hello. Sir, only 5 minutes is remaining. Shall I end the class? Okay, okay. Students, let me end the class today and let me continue tomorrow. Thank you.